You will often be asked to calculate what happens when objects smash off other objects or bounce off other objects. If you're writing a computer game, this is a very common situation where guns bounce off walls or people jump on things. If you're doing particle physics, you'll look at colliding particles. If you're doing astrophysics, you look at colliding galaxies. So how do you calculate this? Well, there are two limiting cases. Limiting case number one is the elastic collision. In this case, all the energy is preserved, none is lost, converted into noise or heat, and the speed at which particles approach each other is exactly the same as the speed with which they depart from each other. So the relative speed in equals relative speed out, and in that case energy is conserved. The opposite limiting case is an inelastic collision. In particular, a maximally inelastic collision. In this case, when the particles approach each other, they end up sticking. So the relative speed as they come in and the relative speed as they go out is zero. Now in reality, most situations lie somewhere in between these ones. And in this case, we use the concept of the coefficient of restitution. Basically, you look at the relative speed of approach and the relative speed of departure, and the ratio is the coefficient of restitution. So for elastic collision, the speed at which they go after the collision is the same as it's before, so it's CR equals 1. In elastic collision, the speed afterwards is 0, the relative speed before is whatever it is, so CR equals 0. And so somewhere in between, so CR here will be less than 1 and greater than 0, and that covers all intermediate stages.